Hello everyone! Sa last video, pinag-usapan natin yung multiple irregular cash flows, kung paano nagmo-move in time yung mga different sizes of cash na pinoproduce natin in that entire period. So this time around, ay nandun pa rin tayo sa multiple cash flows, pero instead na irregular cash flows na. So our topic for this video is all about uniform cash flows. So, uniform meaning equal and equally spaced yung mga cash flows na mag-occur sa ating period. This is also called the ordinary annuity. No? Doon lang tayo sa ordinary annuity. Okay, so mag-drawing tayo ng cash flow diagram para makita natin yung cash flow. So, we have this cash flow diagram here. This is year 0. This is year 1. This is year 2. This is year 3. And say, for example, this is year end minus 1, and this is year end. So, we have this cash flows here. So, ordinary annuity or uniform cash flows, ang sinasabi dito is that we have the same cash flow that is equally spaced all throughout our study period or the time period that is given. So, say for example, our cash flow is denoted by A. So, lahat ng cash flows, regardless kung kailan siya nag-occur in the period of time that we have, ay equal lang. And it is equally spaced. Paano natin kukunin naman ng ang future value ng ganitong klaseng multiple cash flow? So, uniform siya. Essentially, ang ginagawa lang dito is lahat ng individual cash flows na nag-occur in time ay dinadala natin sa future. So, this, say for example, f sub 1. And then, this cash flow here na nag-occur sa year 2, this is f sub 2. Sa year 3, this is f sub n. F sub 3. Sa n minus 1, this is f sub n minus 1. And lastly, this one is just basically f sub n or just a dahil nandito naman na siya sa future time. So, this kinds of uniform cash flow scenario is called annuity. Di ba, ang ginagawa lang dito is we take the sum of all this present value of each individual cash flows. The resulting figure will be our future value. So, to get the future value, we can do summations from f sub 1, f sub 2, up until f sub n. So, dahil future value lang naman siya ng individual cash flows na ito, so we can also write this in this way, no? So, we can have f sub 1, yung galing sa time period 1, is just basically yung cash flow na A ay idadala natin sa future na merong n-1. Merong n-1 time periods in between. So, from 1 to n, so meron siyang n-1. So, para maidala siya sa future, you would multiply 1 plus I, no, sa ating original cash flow by n-1 times. So, yun yung exponent. And f sub 2 is just basically a times 1 plus I raised to n-2 and so on up until such time na umabot siya dito sa n-1. So, in this case, so this is 1 plus I. Ilang period ba from n-1 to n? Diba, isa lang naman. So, this is raised to 1. And lastly, A times 1 plus I raised to 0. So, ito yung last term na yan. Pwede siguro nating i-simplify itong equation na to. So, we have this. So, i-rewrite natin. So, this is just basically 1 plus I quantity raised to 0. So, this is just equal to 1. So, we can write this as A plus A times 1 plus I plus 1 plus I quantity squared up until A times 1 plus I raised to n minus 1. Okay. So, yan yung equation natin. So, notice that this equation here turns out to be the sum of a geometric sequence, no? So, this is a sum of geometric sequence or geometric progression. So, or GP. No? So, S sub n. And we know that the sum of geometric progression is given by the formula a sub 1, so the first term in the geometric progression, times r, where r is the common ratio, raised to n minus 1 all over r minus 1. So dito sa given natin, dito sa equation natin, our first term is a, and our common ratio is 1 plus I, and we have n terms. So n is the number of terms that we have. Now, we substitute these values dito sa equation. So we have this a times r, which is a times 1 plus I raised to n minus 1 all over 1 plus I minus 1. Okay? Or masisimplify natin siya in this way. No? So, ito yung 1 dito, mag-cancel lang yan. So, we can simplify this as a, the quantity of 1 plus I raised to n minus 1 all over. So, essentially, we have derived the equation for the future value of an ordinary annuity. So, this is given by f is equal to a times 1 plus I raised to n minus 1 all over I. So, ito na yung formula natin sa pagkuha ng future value ng ordinary annuity. Okay? So, what if nawawala naman ngayon yung annuity value, so si A, and given naman sa atin yung future value ng annuity as well as the interest rate and the number of terms. So, manggagaling tayo dito sa original formula na to ng future value of the annuity. We just simply multiply this entire equation by the reciprocal of this term here. No? Multiply natin siya sa reciprocal nitong term na to. 1 plus I raised to n minus 1 all over I. When we do that, ang mangyayari sa ating left side ng equation ay f multiplied by I all over 1 plus I raised to n minus 1. No? Meanwhile, sa right side, dahil minultiply lang natin siya sa reciprocal niya, so this cancels out. No? Matitira na lang sa right side is A. Rearrange lang natin. And we have the formula for the annuity value given the future value of the annuity as well as the interest rate and the number of terms. Okay, so na-derive na natin yung future value ng annuity natin given the annuity amount as well as the interest rate and the number of terms. So this time around, ang i-derive naman natin yung present value naman ng ating annuity. So we will derive this using our derived equation earlier ng future worth A times the quantity 1 plus I raised to n minus 1 all over I. So ito yung equation na yan. So we will also utilize this equation here, this relationship of the present value and the future value, which is just this. So 1 plus I raised to negative n. In order for us to derive the present value formula from the original equation, so we just simply substitute the equation that we have derived earlier sa future value ng ating annuity to this equation. So we can do that simply by this. So P is equal to F. So we can replace this F by A times the quantity 1 plus I raised to n minus 1 all over I, and then multiplied by, again, 1 plus I raised to negative n. So, distribute lang natin itong 1 plus I raised to negative n dito sa loob ng ating square bracket. So, we have here basically 1. Then, minus n 1 plus I raised to negative n all over I. So, ito na ngayon yung ating equation ng present value of the annuity. And how do we derive again the annuity value? We multiply this entire equation here by the reciprocal of this term, and this leaves us this equation. So, P times I all over 1 minus 1 plus I raised to negative n. So, yan naman yung equation natin ng annuity given the present value of the annuity as well as the interest rate and the number of periods that we have. Okay? So, ngayon naman, ating i-apply yung mga na-derive nating equation sa problem that we have here. You can pause the video and read and understand the problem. So, meron tayong annuity problem here. So, this is year 0. So, gawa na tayo ng cash flow diagram. This is year 0. This is year 1. This is year 2. This is year 3. And so on. Meanwhile, this is year 19. And this is year 20. No? So, sabi sa problem is that magkakaroon ng annual deposit yung mga magulang mo sa isang bank account. No? So, yung mag-uumpisa yung deposit niya 1 year from today. So, today, assume natin that is always year 0, so the present time. And 1 year from today, that is year 1. So, ibig sabihin, $2,000 yung iti-deposit nila sa account. And magde-deposito sila ng $2,000 for 20 years every year. No? Ito yung mga deposits na gagawin ng iyong mga parents. Ang tanong sa atin is, how much money can be withdrawn from this account immediately after the 20th deposit? Ito ay isang sample ng application ng future worth ng ating future value ng ating cash flows. So, di ba, ito ay pupunta natin dito sa year 20. Today, cash flow na to, punta natin sa year 20. Lahat ito actually ay pupunta natin sa year 20. No? Lahat ng cash flows. Na yan. So, basically, sa ating na-derive na formula, ang future worth ng cash flow na to is given by the annuity multiplied by quantity 1 plus I raised to n minus 1 all over I. And what is the value of A? For this case, ang ating A, siya yung $2,000 deposit every year for the next 20 years, no? And ang ating interest rate in this problem is 3%. So just simply 0.03. And ang ating number of periods ay 20. So, 20 years. No? Substitute lahat natin itong given sa ating equation. So, we then have F is equal to 2,000 multiplied by 1 plus I. So, that is 1.03. No? Raised to n, so raised to 20. Minus 1 all over 0.03. And then we plug this in our calculator. So, okay. So, we have 2,000 multiplied by the quantity 1.03 raised to 20 minus 1 all over 0.03. So, close parenthesis. So, your parents can withdraw 53,000 $740.75 immediately after making the 20th deposit. So, dito sa year 20. So, ito na yung amount na kanilang naipon at 3% interest and investing continuously for 20 years. Okay, so we have another problem here. So, i-apply natin ulit yung mga na-derive nating equation earlier. You can pause again the video and read and understand the problem. So, okay. The present value here is 10 million US dollars. Okay. So, at ang interest niya ay 7% per year. So, sabi dito, this borrowed amount must be repaid in equal end-of-year amounts. So, ibig sabihin, equal end-of-year amounts. So, meron siyang babayaran na annuity. No? Yun yung annuity natin. Over the next 6 years. So, this is payable for over the next 6 years. So, nawawala sa atin ngayon dito yung ating annuity amount. We will solve for the value of annuity. Given the present value of the loan, which is $10 million, the interest rate per year, and the number of years. So our annuity can be solved using this formula. No? So we have A is equal to the present worth times I all over 1 minus 1 plus I raised to negative n. So, we have the present worth. This is 10 million. Then, interest rate ay 7%. That is just simply 0.07 all over 1 minus 1 plus I. That is 1.07 raised to negative n or raised to negative 6. Okay? I-plug natin sa calculator yan kung ilan. 10 million times the quantity 0.07 all over 1 minus 1.07 raised to negative 6. Okay. So, ang payment niya every year is 2097958. Okay. So, 2097958. So, ito yung babayaran ng Dell Corporation sa kanilang hiniram na 10 million US dollars. So, every year for the next 6 years. That may be all dito sa ordinary annuity problems. So, see you again sa next videos.